All right, so this is going to be day 3 of programming. This is going to be another relatively short one, but let's get started. So the first slide here is talking about saving your R scripts. So suppose you wrote all of this code and now you want to turn off your computer. Maybe you need to submit it as homework or something like that, right? So what you would do is you want to save it. So you'd want to hit Control S or Command S if you're on a Mac, Control S, and you're on. I'm in my documents here, and I would just save it as code example day 3, something like this. And you want to save it with the .r extension, .r. It'll save automatically if you don't do that. Like for example, if I just do this way, it will save like that as an R file. So then when you have that, you can have all of your R scripts will pop up like this in a little RStudio icon, and you'll be able to open them back up in RStudio, and it's really just a text file. So it's you can save it as a TXT also. But anyway, you're gonna want to save your R files with a .r extension, which will do automatically if you just hit save. I'm not gonna save it. I don't care about this code, so I'm just gonna hit cancel here. But you could hit save. Anyway, the next thing we can talk about is comments. So I've been commenting this whole time. So I've been writing these little hashtags and then something afterwards. So that just means it just tells R to ignore everything that comes after this. Is just don't even look at it. Just ignore it. This is just for readability. So good programmers, who people that you should strive to be like, comment a lot of their code. So they'll always have a lot of English or whatever language you're speaking in there in those scripts, so you can kind of understand in English what this means. Because if you're not familiar with this, right? If this was, suppose you're perfect at R, but you don't understand Python, if there's a bunch of Python code that you need to convert or something like this, comments would be really helpful because it would tell you, here's what's happening in Python or in R or something like that in this language. And here's what I'm doing in English, so you can convert it. Or if you write a whole ton of code, for example, if I wrote all this code before, I come back to it in, even 2 weeks, I come back to it and I'm lost because I don't remember what I was thinking then, and I don't remember why I made certain choices. So comments are super important. So for example, this would be a comment, nothing happens. But if I just try to write regular English here, it gives me an error because it's not the heck I'm talking about. One more thing about comments is if you put 4 hashtags at the end of it, this little arrow will pop up. So for example, if I get rid of this, that arrow goes away. But if I have that arrow, I can actually condense a lot of my code. Like for example here, so for a lot of these, I actually forgot to put those 4. But we'll talk about these in a second. So anyway, you're able to condense these. So it's it makes your code a little bit nicer. So if we're talking about comments, we talk about comments. If we're talking about directories, we can talk about directories. So for example, for here, we're going to talk about directories. So what directory is pretty much just where does your data live? Where are the files that you're going to try to read in? Where does that live? So if I hit get WD, it's going to give me the file path. So C:/user/AlexC, that's the name of my computer, and then documents, right? But maybe I want to switch it over to desktop. So I can just type in the full file path. I can say, okay, set working directory desktops. So now my working directory is on my desktop. Further, maybe I want to look, let me minimize this for a second. I have this folder on my desktop here called Empirical Workshop. Sorry, I want to do that. Okay, it's called Empirical Workshop. This is something that we did in July. Has a bunch of R stuff that I could even share with the class if you're interested. But anyway, what I'm going to do is I'm going to say, okay, my working directory, my desktop, maybe I want to make my working directory my Empirical Workshop folder. But here I'm just going to list the files. So if I just do list.files, it gives me data, R files, a readme.txt, and scraped HTML. So if I open up this folder, that's exactly what's in there. So this is just essentially being a little file reader, but just in like programming text version. But yeah, so I can list these files. Beautiful. So let's talk about importing data, because we all have data in Excel that we want to import. So for example, we have this set WD. So we're going to set our working directory as Alex C, desktop, empirical workshop data. So because I'm already in desktop, I can actually just I can remove these and just say, because I'm already here, I can just do this and it will work. But if you want to be very specific, you could do it this way. Now, maybe you have a super long string that to get to the data section. Like for example, if we go here, go to data, right? So this is where my data lives. So if I just hit Control C or Command C if you have a Mac, just copying this, you can hit paste and it'll just give you the actual file path for you. All you have to do is get rid of this file : / / / delete that, cut it, move it over here. It's exactly the same. So it's really easy to find your file path if you just copy the file you're interested in, or you copy the folder that you're interested in. So over here, I'm interested in this data folder. So now I'm going to do list.files. So again, I have bidding data, no extension, no dot, right? That means that it's not an actual file of any sort. Nix.csv, sharks.csv. So we're going to work with CSVs a lot in this class. It's just means comma separated value. So instead of having an Excel file or anything like that, we're going to call it a CSV. So pretty much what that means is here would be a blank notepad, super basic text file, right? So if we wanted to write down that data that we had before, we would do something like this: name, grade, what was it, state. You would have Alex, grade was 100, state was New York, and you have Kerry, I don't remember what the other one was, let's call it also 100, Ohio, and and so on, right? So this would be a CSV. So these values, each thing is separated by a comma. So that's able to read into R very, very quickly. Now, if you're in Excel, you open Excel up. So if I have Excel, suppose I now have name, Alex, Kerry, James. Oops. I have grade, let's say 100, 90, 80. He's from Texas, she's from Ohio, I'm from New York, and we'll call it state. So suppose this is your data set in Excel. Typically what you'll do is you'll just save it as data. You'll save it as an XLSX or something like that. Rather, you want to click this and go to CSV, comma delimited. Click on that. We can hit save. So we need anything here. So I'll do example. Save it. X out. So that's how we're going to save Excel data. If you're going to use Excel, and I'm going to try to push you away from that, try to make you learn R, so you have to save your data in a CSV format, or download it in a CSV format, or something like this. It takes a little getting used to. You can't use formulas in a CSV. All the Excel functionality, all the highlighting, all the colors go away in a CSV. But it's way easier to use in R, and you can start really learning it if you use the CSV. So anyway, what I can do now is I can set my working directory, list my files. Now I have that extra file, example.csv. I'm just going to read in this file called nix.csv. I'm going to save it as nix. So this is going to read my file. The strings as factors, pretty much what it's going to do is, instead of converting names and things like this to a factor variable, as we had before, where it was like Alex and whatever was a factor, had levels, we're just going to read it in as pure text. So if we read it like this, we have Nix going to exist here. So we have the Nix roster from 2019, I think it was. So about 23 players, and the college, how tall they are, how heavy they are, blah, blah, blah. This is how you would read in data. I don't care that it's the Nix roster, but it's a CSV and it has data. So that's how you would read that in. So you can see here, there's the data. Okay, packages. What makes R so awesome is that, well, one, it's free. That's the coolest thing. But second, it's an open source language. So what that means is somebody else in Texas can write code, can write functions for you, like how we were writing functions. They can write really complex statistical functions, and they can put them online as libraries. So in other words, I can start to, we can read these libraries and use their code, and we don't have to wait for new updates, Microsoft to update or something like this. People are doing it all the time by themselves. So it's pretty amazing that you pretty much have the whole collection of people who are producing code for this. So it's pretty cutting edge. It's pretty amazing. Anyway, suppose we want to use these libraries, Stargazer and this library Scales. Stargazer is what we're going to use a lot of the time for outputting regressions, and Scales for plotting. So before you load any package, you have to do something called install. So you have to install these packages. So for example, I'm not going to run this because I already have Scales installed, but you'll run this and you'll see a little loading bar come up. Some red message will come up here, blah, blah, blah. And then you're done. Once you install a package, you never have to do it again. So you can just get rid of it. You have to do it the first time though. This will not work unless you install it. Because what it does is it takes the code, puts it onto your computer. What this is doing is saying, okay, now that it's on my computer, I want R to read those functions. So I just did library Scales, library Stargazer. This little message, please cite, comes up. This is an academic package, so this guy wants you to cite him. It's well-formatted regression and summary statistics tables. So this is going to be really, really cool for what we're doing. So now we have these two things written and loaded up. So now setting up an R script. Okay, so you open up a new script, you're ready to write your program, you're ready to do some analysis. How do you start? What's the first thing you write? Well, you might want to write down any sort of library that you think you might need. So for example, a lot of the stuff we're going to need to use is going to be Stargazer. We're going to have to look at a lot of output in table format. So we're going to want to use Stargazer. So let's select that one. So the first thing we want to do is list all of our libraries at the top, right? So maybe we want something called RVest. That's a web scraping package. Maybe we want to do something like Scales, right? We want to use all these packages, suppose. The next thing we want to do is this thing called rm list equals ls. This ls, will list all of the things in your environment. And what this rm does is it removes it. It cleans it. So be very careful with this, but I always put it at the top just so I can start with the fresh workspace. So for example, if I do this, everything's gone. So this is something I always want to put at the top, but I want to be careful before I run it. The next thing I want to do is I want to set my working directory. So if I do this, I've now set my working directory. You can even see it here, Virgo Workshop data. And now let's talk a little bit about plotting. R has super powerful plotting capabilities. We're not going to go over all of them, and we're not going to spend too much time on them, but I'd like you to know some of the basics. So I've put some information here. In the slides, we talk about ggplot2, which is a pretty powerful plotting package that people have made, but I'm just going to stick with the basics and that Scales package. That Scales package allows you to use opacity, so you can plot 2 points over each other and you can kind of see through both of them. So anyway, let's read in our NICS data. So I'm going to copy this, put it here. So this is what the top of my script would look like, right? So I read these in. I have NICS here. We can view NICS. Pops up like this. Looks great. And maybe we want to just plot weight, right? We want to just plot the weight. We want to see what weight looks like. And it's a little small here, but we get this, right? So it looks like just a random plot. Not sure what I was expecting really, because it just kind of is bouncing around. But that's because we're just plotting the weights in order. this is the first row, this is the second row, this is the third row. There's really no meaning to this plot other than here's what weights look like. Maybe you can kind of like look like, okay, well, what's the average? Maybe the average is about 220, something like that. That doesn't help us too much. Rather, maybe we should plot height and weight. So we have height in inches and weight here. Let's plot them against each other. Let's make a scatter plot, right? So now I'm going to plot height in inches on the x-axis, and the y-axis, we're going to plot weight. So we plot these two things. We have the Knicks players' height and weight in inches and in pounds. So we have this relationship, which is pretty obvious, right? As you get taller, you're going to get heavier. But we can add a bunch of nice effects here. We don't have to just stick with this basic thing. That's really, if you were to show this to somebody, they might not understand what the heck is WT, what is HT inches. That doesn't make sense to me. So rather, maybe we want to add in a bunch of other stuff, right? So we want to add this PCH is going to be the plot type. So instead of a circle, we're going to have a filled in dot. We're going to color them blue. The main title is going to be Knicks players. This Y label is going to be weight in pounds. This is going to be height in inches. This is going to be a much more informative plot. And all of a sudden, you're dealing with a much nicer looking graph. Now, finally, I'm going to do one more thing where I'm going to change. PCH is going to be the same color. Instead, now I'm going to use this thing called alpha. This comes from the scales package. You can only use this if you install the scales package. What this does is it takes two arguments. You take the color and an opacity. We're going to leave the labels the same. These are the limits. So I'm going to, instead of letting this pick the default limits on both sides, I'm going to specify them myself. There's no reason for this. It's just something I decided to show you guys. And this last thing, CEX, that's going to be the size of the dot. So what I'm going to do here is I'm going to make the size of the dot based on the Knicks EXP, which is experience. So we have 1, 2, 5, 1, 2, R, 5, 3, 1, right? So if this was just a bunch of numbers, we could just use it regular. But because there's an R, that means rookie. That means they have no experience. So what I'm going to do is I'm going to say, if you see an R, put a 1. Otherwise, make it a number. So convert it from a character to a number, and then add 1. So 1 will be 2, 2 will be 3, 5 will be 6, but R will be 1. So now we have some sort of like size ordering. And if we plot this, it looks pretty nice. So there's a warning here because of this as.numeric, because I'm doing this, we're going to have some NAs put in there because it's trying to convert R to a number, but we're already handling if it equals R, put it a 1, otherwise plot like this. But it already looks really nice, and you can already see there's some sort of relationship here. Again, there's no reason for me to include this thing right here, this CEX. So if you wanted to, you can just cut it, just do CEX equals 1, make all of them the same size, right? Looks like that. But you can see that there's some sort of relationship here. And what we're going to start doing is analyzing, well, what is that relationship? What happens if my player grows an inch? How much weight will he gain on average, right? So that's going to be kind of the basics of econometrics. There's a lot more to learn for programming, but for the basics for right now, if you guys can study this and kind of nail these few topics, I think you'll be in a really, really good spot. So try the homework out. Send me some emails if you're having trouble. But yeah,